Alright, we're going to be looking at subatomic particles today, and one of the things that we need to know about subatomic particles is that there are 3 subatomic particles. You can see them listed in this data table. We have protons and neutrons, both of which live in the nucleus, and they have the same mass. That's important to note on your test review. We also need to know the charges. So protons are positive, neutrons don't have a charge. They are neutral. Electrons are kind of the outsider. They live outside the nucleus, away from the protons and the neutrons. Their mass is incredibly small. So 5 times 10 to the negative 4th, 0.0005. So we're looking at an incredibly small mass, and their charge is negative. We need to be able to identify off of a periodic table, which you should have in class, what some of the features are. So we're going to be looking at the atomic number, the symbol, and then of course we need to know the mass as well. So the atomic number tells us how many protons are in the nucleus. So you need to make sure that on your periodic table you know which number is the atomic number and which one is the mass number. The atomic number is going to increase by 1 every single element. It will be a whole number, no decimals of any type. And the atomic number is unique for every single element. No two have the same one. The elements are different because they have different numbers of protons. So every element from hydrogen all the way up have different numbers of protons, and that is what make them different. So their atomic number equals the number of protons. The atomic number helps us to identify which element we have. So if I say that you need to find number 15, we know that that one's phosphorus. So it helps us to find them easily as well. And if our atom is neutral, the only way that we could have a neutral atom is if our plus charged elements and our negative pieces balanced each other out. So in a neutral atom, your number of protons are going to equal your number of electrons. Now we also have that mass number that we saw on the previous slide, and that's an average. But your mass number is your really is your nucleus. It's what the mass of the nucleus is. And since your protons and your neutrons have the same mass, and electrons are so very, very small, the mass really comes from the protons and the neutrons. So that's what this equation is, that the mass is equal to the neutrons and the protons, both of which are in the nucleus of our atom. The mass number is the mass of a certain isotope, and the mass number technically is not on the periodic table. The mass that you see on your periodic table, because it's in decimals, it is an average. So for instance, carbon, 12.01. It is an average mass for carbon. There's actually several different forms of carbon, and they all have a different number of neutrons, which make the masses different. So we average the masses of the different types of carbon together to get what we see on our periodic table. So we're going to do a practice problem. You need to make sure that you have a periodic table out, because if you notice in the question, we need to know, or we need to find atomic number 34. We don't even know what element we have, so we need a periodic table, and we need to find element number 34. And notice that it has a mass of 78 based off of this problem, and we want to find the number of protons. So remember that the atomic number by definition is the number of protons. So in this case, the number of protons is going to be equaling to 34, because that's our atomic number, is 34. We also need to know the number of neutrons. Now neutrons can be found from the mass number equals neutrons plus protons. So if the mass is 78, that is equal to our number of neutrons plus our protons of 34. And so neutrons is going to be equal to 44. Our number of electrons. 2 slides ago we said that if the atom is neutral, your protons, which are positive, have to equal your electrons, which are negative. And this doesn't say that our element has a charge, so we're going to assume that it is neutral, and therefore we have 34 electrons. And now we need to know the symbol and the name. So we need to find number 34 on our periodic table, and notice that it is symbol capital S, lowercase e. Make sure that if it does have two letters that the second one is lowercase, and the name of that one is also on the periodic table, and it is selenium. So that would take you through your first practice problem of how to use the periodic table and kind of take some of those numbers off of there to help us find our protons, neutrons, and electrons. There are two different ways that we can write the symbols for our elements. Okay, we can have something that looks like this, and when we have a symbol that looks like this, we have two numbers. We need to know what those numbers stand for. So you need to know that when you have your a symbol, okay, this X represents whatever symbol off the periodic table. You know, of carbon, we'd have a C. In this case, we have AU, so we're looking at gold. The mass number is the top number. So the mass number being the 197, that's the mass. So that's protons and neutrons together give us that number. And the bottom number is the atomic number. So if you look up AU, gold, on your periodic table, you're going to find that it is number 79. So if we wanted to know the number of neutrons from this example, we would need to take our mass of 197 plus, it was equal to our neutrons plus our protons. And we could calculate neutrons using that equation every single time. The other shorthand way of writing out a symbol would be writing out the name of our element, gold, and putting the mass. The atomic number you can get off the periodic table, so in this shorthand way you don't write the atomic number. You would have to look gold up on the periodic table to find its atomic number. So those are two possible ways that we will be using to write our elements in a shorthand version. Now, we mentioned isotopes a few slides ago. Isotopes are atoms of the same element. So we're looking at different types of carbon, different types of chlorine. We're not comparing two different elements together. And the atoms are going to be, since they are the same element, they have the same number of protons. Same number because it's the same element. What is different between them is the mass number is different. These are things that I'm highlighting should be things that you need to remember for the test. So the protons are the same, mass numbers are different, and they also have different numbers of neutrons because mass is protons plus neutrons. So if the mass is different, the neutrons need to be different as well. And this is just a picture of sodium. Notice that sodium has, in this case, 23 on top to tell you the mass is 23, but in this type of sodium the mass is 24. The bottom number, the 11, sodium has 11 protons. It's the atomic number of sodium regardless of what type you have. But what makes it unique, what makes it different, is the neutron number. In each one of these, the neutrons is different. Alright, another practice one. Now we don't have a word problem. We have our symbol off to the side. So we need to know what those top and bottom numbers told us. The number of protons, okay, remember protons is equal to the atomic number. So the atomic number here, the one that's on the bottom, so your protons is equal to 11. When you're doing neutrons, neutrons is the mass minus the protons. So 24 being our mass, we are trying to find our neutrons, but we know we have 11 for our protons. So our neutrons is going to be equaling 13 in this example. The number of electrons that we have, again, protons are going to equal electrons in most cases. We'll get to some examples where they don't, but right now everything's neutral. We don't have any differences as far as that's concerned. So our electrons, since I ran out of room, is also 11. And then the atomic number. Now the atomic number is the number of protons, but you can also find it here. The bottom number tells you the atomic number, so that would be 11. And then the mass number. Now the mass number is what that top number represented. So this 24, that's our mass number. Or we could also add our protons and neutrons together, and that would give us, again, our mass of 24. And then the name. We need to look up atomic number 11. So find number 11, or you could search through the periodic table for Na, and you would find that it is sodium. Alright, another practice. We're going to go through this one a little quicker, and you're more than welcome to pause the video and walk through these. You definitely need to make sure you know how to do this. But if you have already looked through the protons and the neutrons, the electrons, atomic number, mass number, and the name, then by all means you can pause this, try it out, and then check your answers just to make sure that you are correct. But again, the number of protons would be 35, because that's what this number here is representing, is our atomic number. And the atomic number, by definition, is the number of protons. We also want to know the neutrons. The neutrons would be our mass minus our protons. And so we would have a 45 neutrons. And electrons, remember that protons are equaling electrons because protons are positive, electrons are negative, and we want these to be equal to each other. So that would also be 35. The mass number is the top number that it gives us. The way they drew our symbol, that's what the 80 represents. And then Br, you could either search through the periodic table for the symbol Br or find number 35, and it is bromine. Alright, now this next practice problem, you need to look at these 4 different isotopes, 4 different possible symbols, and some of these are referring to the same element. So keep in mind from our notes we said that elements are unique because of their atomic number or their number of protons. So if they have the same atomic number, then they are the same element. And the atomic number is the bottom number listed. So we have a 92, a 93, a 92, and a 92. So everything that's a 92 is referring to the same element, and we could look up the element because it does say which element are we referring to. Look up number 92, and 92 is equal to the symbol uranium. So this would be a U-234 with the 92. If we've solved for what that X is, it would be uranium. Alright, you're going to be trying this one and I'm going to be checking it in class. So hopefully you do this and you get all the right answers. But these are isotopes of carbon. We're not changing what these mean. The top number is still referring to the mass. The bottom number is referring to the atomic number. And for each one of these examples, you want to find the protons, the neutrons, and the electrons for each example. And you want to have that in class when I come around and check them. Hope you have a great evening.